We're looking at Calculus Notes 2.62 P2 Physics, continuing our conversation about physics and calculus and how are they related. So we have this formula, this negative 4.9 t squared plus v sub o t plus s sub o. Recall that negative 4.9 is the coefficient we use when we are talking about meters. We use the negative 16 as the coefficient if we're talking about feet. V sub o always represents our velocity at time 0. So that can be many different things. T is our time. S sub o means our initial position. Remember that position is S, velocity is V. S sub o means the position at time 0, so that's the starting position. So let's look at number 1. A ball is dropped from a building 200 meters tall. So we're thinking of this tall building dropping a ball from the top. And it's 200 meters tall. It says determine the position function. Well, here's our position function right here. F of t, or we can call it S of t if we prefer. I'll use the S. S of t is equal to negative 4.9 t squared. That's never going to change. What can change is the velocity, the initial velocity. If I'm going to drop something, that velocity right there, the second before I drop it, is 0. So this velocity is 0 times the time, that's 0, plus S sub o. S sub o is the initial position, or the initial height. Remember, position and height mean the same thing. So this is plus 200. So there we go. There's our position function. Part B, determine the velocity function for the ball. Well, remember how once we have the position function, the velocity function is the derivative of the position function. So our velocity then is going to be negative 9.8 t. That's all we have to do there. Determine the average velocity. Average velocity means something different than this. See, this represents the instantaneous velocity. Instantaneous. Average velocity, all we do is we do the height at time 1 minus the height, oops, not F, height, at time 2, and then it's divided by the change in the time. That's how we find the average velocity. So I want to know what was the height at 1 second. So to find that, I find S sub 1. I go back to my original function. If I plug in 1 squared, so that's going to give me 200 minus 4.9. So that's going to be what, 195.1? Okay, so now I have to find the position or the height at 3 seconds. Grab my calculator for that. So I'm going to have negative 4.9 times 3 plus 200. Just plugging that into my position function. 185.3. So now I want to, just want to double check that. Okay, I wanted to do my height. I'm going to do my second height, which is 185.3, minus my starting height. So I'm basically just finding slope. I'm doing my y sub 2 minus my y sub 1 over my x sub 2 minus my x sub 1. That's all an average rate of changes, is it's just basically the slope. So 185.3 minus 195.1, that gets divided by 2, and I get negative 4.9. So my average velocity is negative 4.9, and that's going to be meters per second. Now, the reason that it's negative is because that's telling us direction. All that's telling us is that it's falling. Okay, that's what that negative on that means. All right, now we're going to find the instantaneous velocities at time 1 and time 3, at 1 second and 3 seconds. So here's our velocity function. So to find v of 1, I'm just going to plug that into my velocity function. So negative 9.8 times 1, that gives me negative 9.8, and that would be meters per second. So that's the exact velocity at 1 second. So that just tells me it's falling. That's all that means. And now I'm going to find the velocity at 3 seconds. So negative 9.8 times 3. And that gives me negative 29.4 meters per second. And if you think about it, that makes sense, because if I drop something, at 1 second it's going to be going slower than at 3 seconds because of acceleration. If I drop this, it starts off slow and then it picks up speed. All right, part E. Find the time required for the ball to reach the ground. Well, the only thing I know about when the ball reaches the ground, I don't know how fast it's going, but I do know its height. So I have to go back to my original function and look at my height function. I want to know, when is it that the height is 0? Because this represents the height function. So I'm going to solve that. That'd be 4.9t squared is 200. Just going to do that on my calculator.
Nia Raya West, please come to the front office. You have a phone call. Nia Raya West, come to the front office.
Okay, and really this would be plus or minus, but in this case, because we're talking about time, we just would use the positive. So it's 6.39 seconds to the nearest hundredth. That's how the time that it takes for it to hit the ground. Now we're asked to find the velocity of the ball at impact. Well, we don't know that. It's falling, it's going faster and faster as it, has acceleration acting on it. So now what I'm going to need to do is I'm going to need to plug this time, because this is how long it takes, back into my instantaneous velocity function, which is right here. So I have to do v of 6.39. So plugging that in, that's negative 9.8 times 6.39. That gives me negative 62.62 to the nearest hundredths meters per second. So that's how fast it's going at 6.39 seconds. All right, questions on that? Hopefully not. All right, then it says, what is the velocity of the ball when it has fallen 90 meters? This takes a little bit of thought. All right, so let's kind of draw a picture here. Here's our ball, starting off 200 meters above the ground. When it's fallen 90 meters, so it's fallen a distance of 90 meters, think about the fact that now it would be 110 meters above the ground. So I need to know, in order to find the velocity, look at the velocity function. It requires me to know time. So I have to know time. I don't care about height. I need to know time. So what is the velocity when it has fallen 90 meters? Well, its height is now 110 if it's fallen 90 meters. So I would have to take that height function, which was this, and I want to know what t value makes that 110. So I'm going to subtract 200. So figuring this out, I just need to do 90 divided by 4.9, get that answer, take the square root of that answer, and I get 4.29. I'm also going to show you how to keep this answer exact. As you get on into higher level math, you want to use exact answers. So what I can do is I can store this answer. You can even just pull it back up on these newer calculators, but it's kind of cool to store. If you look down here by the number 1, here's your store button. So I can say store that, and I'm going to store it into time, into t. See right there is the t. So to get to it, it's green, so I have to do alpha 4. So now it's saying, do you want that answer to go in to be time? And I'm going to push enter, yes. So now it's in there. So now I don't even have to look back at it. I know what my t value is. So now to find the velocity, v of t is going to be, my velocity function is negative 9.8 times t, and I stored my t, So I just need to do negative 9.8, bring back up that t by doing alpha 4. So now it's going to do negative 9.8 times that t value. And like I said, of course, on these newer calculators, I could just arrow up and get it, but this makes it more interesting. And so we get negative 42. And that's the exact answer. So that's going to be more exact than if I had rounded it. See, if I had rounded it, I would have done negative 9.8 times 4.3, and I would have gotten this answer. And that's a little bit further off. The more we round, the more further off our answer is going to be. So the best answer is negative 42 meters per second. We'll give you some leniency on how you write these answers, because depending on how people round, but when you round too early in a problem, then every time you use that answer, the answer is going to get further and further off from the exact answer.